Yeah, it's officially the biggest midget in the game. I don't know. Make way for the insult.
Comparable interfaces. Comparable interfaces. Now we have to examine what is comparable system. It has been defined in the Java lang package. To use an interface, a concrete class must specify that it implements the interface and must declare each method in the interface with the signature is specified in the interface declaration. A class that does not implement all the methods of the interface is an abstract class that must be declared abstract. Implementing an interface is like signing a contract with the compiler that states, I will declare all the methods specified by the interface, or I will declare my class abstract. Compile time polymorphism. For compile time polymorphism, we can take the example of method overloading. In this case, method can with same name but the different arguments is called method overloading. We can further describe this with the following example. Runtime polymorphism. Method overriding occurs when child class declares a method that has the same type of arguments as a method declared by one of its superclass. Method overriding forms runtime polymorphism. By default, functions are not virtual in C# and so you need to write virtual explicitly. While by default in Java, each functions are virtual. You can further clarify method overriding with the following example. Practical example. I describe what interface and abstract classes are, how to create and use them. But the question is, why do we need to use interface or abstract class? Is it useful? What if we don't use them? Actually, the primary reason of using them is we are going to do polymorphism, a term that object-oriented developer might be familiar, but they seldom implement in the real-world project. This example also explains one of the refactoring principles, replace conditional with polymorphism. I summarized and rewrote the article from Bosman's blog in my. Rather than giving some boring definition of polymorphism, let's do it with a real-world example. It will be better. Here's our story begins. Sometimes we would create the online application for taking the survey. The questions and answers typed in surveys are easily changed. Some of them are required the respondents to fill in the text box. Some of them are multiple choices with single answer. Some of them are multiple choices with multiple answer. From the scenario, we probably will set up with 3 classes. This class would be a section of the possible answer. Maybe it could be text and value. With me so far, there is nothing outrageous things here. We have a simple hierarchy survey has questions and choices. Now let's conduct some codes that will make us easier to understand, starting with the lowest level choice. Practical examples continued. Luckily, polymorphism comes to offer the better way. Let's see how to take the advantages of it. We see that all questions have something that is common, general. They have the questions, most of them have choices, ability to pre-select answer, ability to display the answer. But make it simple first. We will include choices in our interface now. With that in mind, we could create an interface with these properties and methods. Here's our interface would like this. What does it do for us? Here, we know that any question that inherit I question must implement these 2 properties. We don't need to use toString method because all class inherit the toString method from system.object. Now from the iQuestion interface, let's create the 3 classes. One called single radio, one called single dropdown, and one called multi-checkbox. Benefits of polymorphism. Now we are going to discuss the benefits of polymorphism. One is simplicity. If you need to write code that deals with the family of types, the code can ignore type-specific deals and just interact with the base type of the family. Even though the code thinks it is using an object of the base class, the object class could actually be the base class of any one of its subclass. This makes your code easier for you to write and easier for others to understand. Other one is extensibility. One subclass could be added later to the family of types, and objects of those new subclasses would also work with the existing code. Advantages of polymorphism. Polymorphism is the third essential feature of an object-oriented programming language that after data abstraction and inheritance. I have seen lots of people not clear with that polymorphism is, or they often stumble when someone asks them to explain. So be very sure what it is. Just remember this. Poly means multiple and morph means type shapes. So polymorphism deals with one thing which can have multiple shapes. Polymorphism can be applied on both data types as well as on functions. I will highly advise you to check wiki link on polymorphism. Polymorph allows improved code organization and readability as well as the creation of extendable programs that can be grown not only during the originally creation of the project but also when new features are desired. If you still don't understand it, then post it in forum and I will see what I can do it for you. Disadvantages of polymorphism. Polymorphism reduces readability of the program. One needs to visualize runtime behavior of program to identify actual execution time class involved. It also becomes difficult to navigate through classes implemented. Even sophisticated IDEs cannot provide this navigation feature. This adds to the maintenance cost to some extent. Summary. Now we are moving to give a summarizing about the lessons we did so far. In the beginning we described uses in Perl and Ruby programming languages and uses of object-oriented programming with the use of animal, extended superclass and weekly pay of several. Interface reference variables describing side effects, compile time and runtime polymorphism differences between them, an illustration of practical example of polymorphism, and finally benefits, advantages and disadvantages of polymorphism.